But what we did in this study was made comparisons within a single person. Many would be familiar with single leg exercise training. Traditional way of doing on a bicycle, of course, is quite awkward. A lot of hip flexor involvement. And so we took some clues from some work that was done in Australia a couple of years ago, and basically come up with this model that involves counterweighted single leg cycling. And so it's actually quite simple. You just attach a counterweight based a little bit on the weight of the individual to the opposite crank, and it feels very much like normal two-legged cycling, but of course only one leg is doing the work. It only takes subjects 1 or 2 familiarization sessions to become quite comfortable and familiar with this type of exercise. So it's a much more natural form of single leg exercise, I would submit. And so what we did in the study that's coming up in the Journal of Physiology was we made comparisons within a given individual. One leg would perform moderate intensity continuous training, which involved 30 minutes at 50% of the subject's work max. The other leg would train in a manner such that the total time and the mean intensity and the overall volume was the same. So the only thing that was manipulated here within the same person was the way the training stimulus was applied. And so the opposite leg was doing 4 5-minute repeats at 65% of work match. Again, everything else was equivalent here. If you look at heart rate, you can see the perceived cardiorespiratory and metabolic stress was higher with the interval compared to the continuous exercise. Obviously, heart rate is relatively low, given that the only one leg is involved in doing the exercise. But you can see from the lactate values that it was a significant metabolic stress for these individuals. They performed 6 sessions of the exercise training, so 6 training sessions with each leg over the course of 2 weeks. And we took biopsies before and after training. This is really the money finding right here. What this is showing is the maximal activity of citrate synthase, a very robust marker of mitochondrial content. Open bars are showing moderate training. High intensity training is shown in dark bars. And you can see that following training, there was a main effect in that both groups improved after the 6 sessions of training. But the improvement was superior in the high-intensity interval training group, even though everything was matched except the nature of the training stimulus. We also included mitochondrial respiration markers. So these are various indices of mass-specific mitochondrial respiration. You can see the trend throughout is that high-intensity interval training was superior to the moderate intensity continuous training. Of course, when we normalize this for citrate synthase, there were not differences in terms of mitochondrial respiration. So these are the mass-specific changes that I'm showing here, which I think generally fits with most of the literature that's out there. The other thing that we did in this study was we tried to get at the issue of fiber type. This was a collaboration with Robin Murphy, who works at La Trobe University. Those who follow Robin's work would know that she has a nice method established for identifying and then pooling subgroups of type 1 and 2 muscle fibers. So if you look on the far left, this is now COX-4 protein content. So these are Western blots as opposed to activity measurements. You can see the general trend is there throughout, but here we were not able to tease out a significant difference between the interval and continuous training, but we saw a main effect for training. In the middle, we have type 1 fibers, and on the right are the pooled type 2 fibers, again measuring COX-4 protein content. Not as clean a story or as ideal story as we would have liked to see. We're able to tease out that the type 1 fibers overall had higher protein content of COX-4. And again, you can see similar trends in terms of directional changes. But we're not able at the single fiber level, or at least pooled fiber level, to tease out differences between type 1 and type 2 muscle fibers in terms of a differential response between interval training and continuous training. But Those of you who have done single fiber work hopefully can appreciate at least the effort involved here. Obviously, it's either going to take longer periods of training, greater numbers of subjects, or pooled fibers to potentially pull this out. Nonetheless, based on the whole muscle data and the activity measurements, as well as some of the mitochondrial respiration measurements, I think it's fair to conclude that in this study, interval training elicited superior adaptations, even though the total work was matched, which then suggests that either intensity or the contraction pattern, the start-stop type of pattern that's intrinsic to interval-type exercise, is important for the mitochondrial response in human exercise-induced skeletal muscle remodeling.